Well, hello everyone and welcome back to another video from my channel Highbrook End Model Railway. Hope you're all doing okay. It has been a long time since I sat behind the camera and did a proper video for you. Obviously we've done a couple of train spotting videos since then, but I've not actually sat behind the camera and had a chance to speak to you in person. Obviously I don't speak over the train spotting videos. Two things to address before we start. If you can hear dripping water, it's because the water tank is behind the wall just to the right of the camera and somebody is taking a shower. The second thing is my finger. I was slicing some bread yesterday and had a rather nasty accident with a bread knife. So if you see this, please don't be alarmed. It's to stop me bleeding out all over the wires I'm going to be trying to solder. So what are we doing today? We're going to be replacing that point over there at the end of my finger because I butchered it when I was installing the point motors, because silly me said, oh yes, I don't want to put point motors in. Built the layout, did all the ballasting, and then realised how much of a pain it was to reach all the way over there every time I wanted to change the points. The ones around here aren't so bad, but I thought if I'm going to put point motors on the ones at the back that are difficult to reach, I may as well just do all 19 of them. I think there's 19 sets of points or something like that. So for Christmas, about 8 months ago, I got this set of points, Pico set track, normal number 2 radius right hand set of points, and that's obviously going to be going over there. And while we're at it, I'm going to be adding some signals. So I've got some more of these cheap signals from China. A pack of 5. I bought a pack of 5 because 2 of the points, I think I did this on stream, 2 of the signals, sorry, over on the station area actually failed just before the Christmas stream last year, so I got them repaired very quickly for the Christmas stream. But I bought a pack of 5 as well because for whatever reason, when I did this little layout area, I added a set of points for the second radius to the third radius crossover, but didn't think to add one for the third to fourth radius crossover, and several people have pointed out on videos and on streams it does look a bit daft. So today that's what I'm going to be doing. I'm going to be ripping up all of this ballast, probably from about here to just round that corner there, so that I can pull the track pins up, lift the point up after I've removed the ballast, drop this new one in. It's not going to be that simple, but hopefully it doesn't take me all day. Put the point motor back through here, and then we're going to wire up 2 signals, one over here and one over there, to protect the third radius to fourth radius crossover. So let's get in a bit closer and you can see exactly what's happened. So basically what happened was, instead of installing the the point motors and deciding that I wanted point motors before I did all the ballasting, and before I laid the track, I laid the track, did the ballast in, left it for a few months, and then thought it is a really big pain to reach the back of the board to flick the points over by hand, and especially when shunting, having to dart over there to change the points and then back to the controller, it was a pain. So as you've already seen, I think in a video and a stream now, I've got a full panel with all the point motors, did all that wiring a year and a half ago, I think, and because obviously I'd laid the track and pinned it down and glued it, it was quite difficult to fit the point motors, because you've got to obviously drill a hole so that the tie bar of the the pin of the point motors, you can just see sticking up there. Basically that goes through underneath the board. You attach the point motor to the underneath of the board, and there's a pin, and then the solenoid just flicks, goes through the hole in the points, and then the solenoid goes to one side, change the points that way, goes to the other side and changes the points that way. And obviously because I'd laid the track, it was quite difficult to drill the hole because the track was on top of where I needed to drill the hole. So what I ended up doing was I ended up poking a very fine drill bit actually through the hole in the point underneath, and then with a router bit in the end of my rotary tool, ended up choveling away all the wood underneath for a large enough path underneath so that the pin could move backwards and forwards from the point motor to change the points. And I think, as I said earlier, there's 19, something like that, 19 or it might be 21 sets of points on this layout, and I only managed to wreck one of them. The tie bar of this set of points here met the end of my quite sharp router bit in my rotary tool and completely destroyed it. So I tried to, fix it with super glue and bits of plastic and metal, but it's just not reliable, and the electrical contacts, to go this way or to provide power into the points that way is just not good enough. So we're going to be replacing the point today, so we need to rip up all the ballast, take the track pins out, put the new set of points in. I won't be doing any ballasting today because I haven't got any of this type of ballast. I need to order some, and then we'll wire the signals in, at which point you've probably all fallen asleep by then, because let's face it, the only person who's interested in wiring here is me. And then hopefully by the end of this video we should have the 4th to 3rd radius crossover all nicely working again, and of course with the addition of these signals. I'll put a link in the description to these signals, 2 aspect signals, and I'll explain how they're wired up later. So let's crack on and get ripping up this point. Now, I do apologise if the audio quality decreases. It's because my wireless microphone, which connects to my phone, the receiver with a USB-C, has decided to stop working. The connector's dodgy, so I'm probably going to have to, well, split this open and maybe put in a new USB-C port. But anyway, that's beside the point. We are going to be ripping up this point, and obviously the tool of choice is a chisel, and if necessary, a hammer. So let's begin. These signals are wired in, but they have got enough room to just be bent out of the way, so I'm going to do that to prevent any damage, and hopefully you can see that they're lit against my hand there. I might as well leave them on. So we're going to rip up this point. As I say, the ballasting we're going to have to do at a later date because I haven't got not any of the right stuff anyway. So I'm just going to, possibly to these rail joins here, I'm going to take up the ballast, maybe to here. I'm just going to have to see how much I can get away with, because obviously I'm going to have some leeway to be able to bend this point out and disconnect the fish plates and all that. So we'll just see how we get on. But mainly we need to be taking the ballast away from around this point, and yes, sadly this does mean a lot of loud banging and getting my loft covered in stones again. So it's not going to be easy, so we may employ some time lapse here. So I cleared some of the ballast away around this point, around the side. Obviously I can't really get in the middle, so I'm hoping that once I get the track pins up, I should be able to reasonably easily try and just prise it up. I think I have got a couple of straight pieces of track left, so if I wreck this one it won't be too much of a problem. Obviously that point's scrap anyway, so if I wreck that it doesn't matter. But I'm going to see if I can now try and lift some of the track pins up, and a pair of small cutters like this is really useful because you can use them to get under them and then just lever them up like that. I think I've demonstrated this before actually. It is really quite a useful pair of tools to have. So I'm just going to zoom in a little bit, primarily not to get my head in the way. And I'm just going to see if I can't now prise some of these track pins up, so I can see that there's one there. I've just dropped that, there we go. Right, so now I'm going to see if I cannot lever this up, because as I say, if I wreck the point it really doesn't matter because it's getting replaced anyway. What does matter is saving those insulated rail joiners there. So I have managed to get this loosened off a little bit, as you can see, and I'm very reluctant to try loosening this off because it's already started lifting, and as I say, I may have to glue it. So now I'm just wondering whether it is actually possible to start separating those joiners. Not really on that side. I need to get the I haven't got this end of the point here lifted up yet. Chisels are wonderful. Oh yeah, that's coming, that. Now, have they slid out? No, I think they popped out of those rail joiners. That's not good. Yeah, you can, well, I can see here anyway that they've sort of flared, but I may be able to reshape those. I think I do have 2 left actually. I can't think it was a pack of 10 ball. I think I needed, well, I needed them on all the points where it switches from one controller to another. So how many would that be? That'd be 1, that would be 2, 4. Hang on, 2, 4, 6, 8, 10. 12, I think. It can't have been a pack of 10 then. I wonder if it's a pack of 20. I may have some left, but I'm just not entirely sure, and I haven't been able to find them when I had a quick look this morning. But that's one of the joiners out, and I managed to slide out. Once you've got one set of joiners out, it's easy. Just obviously on the point you've got joiners there, and joiners there, so it's not the most easy. And I apologise if all you can see is my hands. It's not coming. I wonder if I can pop this side out. If I get one side out, because this is loose now, I wonder if I can tease this out here. That rail, that actually might be quite good that rail's broken, because it means I've got a bit more room to play with. Some of the sleepers have broken off round there, but it doesn't really matter because they'll all be covered by ballast anyway. Yes, I think we're coming. Yeah, there we go. So that is the point out, and you can see the bad job I did here with trying to repair this tie bar with plastic. You can just see there as well the pin of the point motor sticking up just at the end of my finger there. Can you see that? You can't see that zoomed in. Just see it sticking up there. Right, so that point is toast. I may save it for the rails, but I'm not going to reuse these fish plates because I think if I've got some, I'll use them, and I'll dig them out in a second when it comes to replacing that point. So let's have a look at these. Yeah, I may be able to reuse those plastic joiners. The rail may just slip in, as long as the rails don't, as long as they're held relatively securely and the rails, don't touch each other end to end or anything like that. It should be fine. So I just decided to unscrew the point motor from underneath, and I'll show you how that looks in, well, God knows how long, when we go under the boards to wire up the new signals. Fortunately, these signals are still lit, so we haven't damaged them. So now we need to think about relaying this point. There's new fish plates on the end here, and I said I was going to change these, but honestly, they look alright then. And hopefully, I can still get the point into the insulated rail joiners. I'll tell you what, I'll just have a quick look to make sure I haven't got any new ones, but if I haven't, we're going to have to try and use those. Yep, it was as I thought. I've not got any plastic ones. Well, if I have, I don't know where they are. I'm starting to sound like my granddad in his garage here. Put something down and then can't find it. I managed to find a glass fusing with the fish plates, and God knows why, but yeah, no plastic ones, just plenty of track pins, thankfully, and normal rail joiners. So we're going to have to try and make do with these. Managed to get the first side into the plastic rail joiner perfectly fine. The second side is actually not too bad. It's not quite as smooth as the first side, but I think it should work, and the rail ends, as you can see there, do meet nicely. Managed to get them in there, and also managed to get them in there. So now what I need to do is find my special hammer. One moment while I find my special hammer, and by special hammer I mean the one I nicked out of my dad's toolbox and haven't given me it back yet. Is this a panel pin hammer, which is really quite useful because you can hammer it on this end and that does roughly fit between the tracks, but then you can also use that end as well, which is quite useful. So now what I'm going to do is replace the track pins, and now comes the challenge of remembering where them were. And luckily these rails that have lifted out of the sleepers, actually when you press this down they do sit nice and flush back in, so I don't think I'll have to glue them, and I don't think I'll have to glue these joints here, which is actually quite good. So that coach is now making it through that set of points absolutely fine. So the next job is the interesting job, and at the start of the video, well, interesting for me, and at the start of the video I said it's the point where everybody's going to be falling to sleep. It is the part where we actually wire this up now. So what we need to do is get the signals, which I have misplaced. No, I haven't there. Signals, I said I'd leave the link in the description for them if you're interested. And what we now need to do is reattach the point motor and do a little bit of wiring to get, obviously, when the road is set like that, we want green ahead. And when the road is set like that, we want green for going into the crossover. So now let's get under the baseboard and let's get wiring that up. In fact, no, actually, let's not get ahead of ourselves. We actually need to drill the holes so that we can pass these through the baseboard. So just to explain the logic behind it before we start, instead of having 4 sets of signals controlling the one crossover, what I'm going to do is what I've done here and what I've done here. Tell you what, I'll turn, no, it's not that one. Yes, it is that one. What I'll do is I'll turn that signal round so you can see what's going on. So this signal here controls the 3rd radius line through this set of points, and this signal here controls the 2nd radius line set of points. So my logic is this: instead of having a green for straight ahead and a red for oh no you can't go into the crossover, and the same over here, what I did was just employ one signal that's dual purpose, if you like. So this signal here and the signal here is indicating for the straight ahead route mainly. So what if I do now is if I change the points, which I'll do manually, just to, if I can get the signal to stay on manually, because they do when I flick them over by hand. Now if I change the route to go over the crossover, you can see the points send it into there and out there. Then this red signal says no, you can't go straight ahead. That red signal, which is normally facing that way because trains run this way on that line, this red signal is now saying no, you can't go straight ahead, but this is the dual purpose, meaning if it's red for straight ahead, that means it's green to go in there, and again, if it's red for straight ahead, that means the points are changed to go in there. So it's not by any means prototypical, and my layout, and indeed if you've seen any of my videos, there's things that I run generally are just whatever I fancy, but that makes sense to me. Hopefully it makes sense to you, and it just means I don't have to do even more wiring than that's already under the baseboards, and it makes sense to me. So now again, if I change to the straight ahead route, we get a green for the straight ahead there, and they don't, these signals don't stay on really unless you flick them over electronically, but there you can see we've got green for straight ahead and green for straight ahead now. So that's the same logic I've applied throughout the layout, and that's, well, that's the logic I've applied for crossovers, because I didn't want, you know, signals all over the place down here and just polluting the place. You can see for turnouts like this for going into the siding, I have got a green for straight ahead and I've got a red for into the siding. But on the crossovers, because, you know, this area is already, you know, I wanted to keep this area as clean as possible, that's the logic I've employed for the crossovers. So anyway, we'll go and drill the holes to get these signals through the baseboards. Just make sure there's no wires underneath. Well, there is, but I'll pull them out of the way with my hand. Let's test that. Shouldn't hit on it now. Yeah, it does. It clears it perfectly. Lovely. Just tilt that to face the correct direction. Yeah, that's fine. That's beautiful. Right, after a spot of lunch, you join me back under the baseboards, where actually it's surprisingly a lot cooler down here than it is stood up there, and it's dropped to a much cooler 29 degrees from 30 degrees, and having acquired myself a drink, sadly not a dark fruits, just a blackcurrant and lemonade. Oh, that's nice. Right, where can I put that? It's time to do some wiring. Now, before we can do some wiring, I want to get this point motor out of the way, which all that means is me getting in where you won't be able to see, pushing this pin up through that hole in the middle of the points, which I showed you about, fixing it in with the screws there and there. And then all the point motor is basically a shaft with 2 solenoids, 2 coils of wire either at the end. You activate one coil, it pulls the iron or ferrous magnetic bar to one side. You activate the other coil, it pulls it that way. That pin moves the point through the hole in the middle of the tie bar, and that's what moves the point. So I'm going to get under the board and fix that in there. You won't be able to see it, so I'll just tell you when it's done. Right, so after a lot of sweat, aching arms and black current, hopefully you can hear that this point motor is now actuating that point up there. So now what we need to do is match or plumb these wires into their corresponding point motors. Now this isn't actually quite as difficult as doing, say, some of the siding points that I showed you, where we know we have a green for the main line, say we set to go on the main line, and a red for the siding. Then we switch into the siding and we get a red for the main line and a green for the siding. It's not quite as difficult as that because, as I said, I want to try and keep this layout on the main section relatively clean, so we've just got one signal for each track, rather than, as I said earlier, a signal for going straight on and a signal for going into the crossover, just to keep it simple and to not clutter the place with far too many signals. So what we need to do is we need to bring a positive connection to this wire and this wire, and then we need to put the red and green into the point motor harnesses, which are these here. All I did was simply extend the connections from here on the point motor, you can see where they're soldered, to the terminal block here, so that I'm not soldering too much underneath. So all I need, when I want to connect something to, say, this wire, all I have to do is plumb it into this spot on the terminal block here, rather than having to get in here and solder. I can literally just shove a wire in there, screw it in, and it's connected to the point motor. I'll do a quick little bit on wire thickness. So for track wiring, I've used thick wire. For point motor wiring, I've used thick wire because I don't want the resistance to be too high, and because I've run a single negative feed all the way round for the point motors, you know, it starts all the way over there, does a massive loop all the way around the layout and comes back. I didn't want to be using really thin wire like this because the resistance would be too high, and then we might have a problem of not enough current getting to these point motors and them not flicking over reliably. For the signals, I have the wires here and the thin wires that you can see here and here. They're only thin because, as I said, LEDs really do not draw any current whatsoever. But for the positive feeds, which I'll explain in a minute, I have kept those thick because, again, the positive feeds for the signals go all the way around the layout, as do the negative feeds for the signals, which go all the way around the layout. So for the track, the point motors, and for the positive and negative feeds for the signals, I've kept those as thick wires because I don't want to lose or generate too much heat in the resistance of the wire, so it's best to keep it thick. But for the short distance stuff, so from here to here, and for the wires that actually just carry the current to single LEDs, they can be nice and thin, and I'm actually going to be using SCART lead wire, or I have used SCART lead wire here and here for the low current stuff. So what we need to do is we need to get some terminal blocks, which I got off my granddad yesterday, and I was going to do this last night until I sliced my finger open. So what we need to do is get a terminal block somewhere in a gap, so roughly here, and somewhere over there, roughly there, to get connecting things together. So I'll quickly go through the signal wiring, which I said earlier. So these are switched negative signals. So this one, the black wire, as I said, normally in DC systems, that's negative, but because it's from China, this is actually positive. So we connect the positive here, and if we connect the negative to the green one, we get a green light. If we connect the negative to the red one, we get a red light. So what I did when I wired this was I took the negative to the point motors, because in the point motor there is an inbuilt accessory switch. So you can put a single positive feed in, say the point motor is switched to go left, it will put the negative output to one contact. When it's switched right, it will put the negative contact to the other one, the negative output to the other contact. And that's exactly how you switch between red and green. These go simply into two connections on the point motor. The switch is one way, the negative gets applied here, we get a red. The switch is the other way, the negative is applied to the green. Now, the negative goes to the point motors because it's a switch negative. The positive just goes to the signals. I did the point motors before the signals, so I just took every connection that I needed to, even if there wasn't going to be any signals in there. I still just took the signal negative to the point motor, and it's a good job really, because as we're doing now, I've decided to add one. The positive feed though, when I did the signals, just goes to the signals, so we don't have a positive feed in here because the positive doesn't come near the point motors. So what I need to do is tap into a positive feed and connect it to here and connect it to here. And then all I need to do with the signals is simply go from in the terminal block and connect these two wires here, the red and the green, into the terminal block, and then when we switch the signal it'll be red one way and green the other. So let's crack on and do that. So first of all, I need to find where the positive connection is, which is this one over here. So I'll stick a wire in there, or I'll get a feed from here and take that one to this positive wire over here for that signal, and this positive wire over here for that signal. So I've done a little bit of wire Jenga and taken a feed from this positive connection here to here into this terminal block, and this will go into there. And I've done the same, taken a positive feed from this terminal block here over here. This will all be cable tied up into the back of the terminal block and then to the positive connection of that single. So now all I'm going to do is bare the ends of these wires here a little bit more, and the same over here, bend them over, thicken the ends up with some solder so that it can connect into these terminal blocks there. Right, so that is the signal wires into here now. Just bending them over, doubling them over and putting a bit of solder just means the screw in the terminal block can grab onto it a bit easier, because these wires are very, very fine. So now the positive is connected to the positives. We've got the two negatives from the signal. Positive to the positive of the signal, two negatives from the signal. So now all I'm going to do is go into this terminal here, connect red from there to red on there, green to there to green on there, and the colours aren't red and green on this one, I think they're red and grey, so I'm going to connect red to red, the small red, which is that one there, small red to small red on there, small grey to the green on there, because I think I ran out of green when I was making that wire, and that should mean that the correct colour signal lights up. If it doesn't, then all I have to do is reverse the two end connections there and reverse the two end connections there. As I say, it should light up the correct colours, red to red and green to green, but if not, all I have to do is reverse the two connections in there, and then it should show the right colour. So I'll go ahead and do that now. So that's one signal done. I've used white in place of green because I've run out of green SCART lead wire. If you're ever throwing anything away that uses a SCART lead, strip the SCART lead. There's 24, I think there's 24 wires in a SCART lead. Yeah, use a SCART lead, strip it open and you get a load of this really good fine wire. It is very fine, only good for low current, very low voltage applications, but it is good stuff to work with when wiring signals. So green to green and red to red. Up above, clearly we have a problem. This signal is to indicate the main line. The main line is set to go straight ahead, but we have a red signal. So all I have to do, coming back under the board, apologies for dodgy camera work, all I have to do is swap the red for the white wire, the white for the red wire, and that should light up correctly. As you can see with that simple swap, we've now got the road set to go straight ahead, and we have the green signal. So we've just got this signal to do now, and that shouldn't take too long at all. As I say, you can logic it out looking at the switch contacts and deciding, oh well, if the switch was set left, that'd be the negative set to that wire, and that'd mean that that light lit up. But honestly, even if you're reasonably experienced with layout wiring, not that I claim to be, but obviously I've done all this, but you know, even if you've got some experience behind you, and especially if you are a beginner, it is just a lot easier just to say, oh well, I'll try them two that way. If it works first time, great. If it doesn't, or it doesn't like it did this time, then swap them two wires over, swap your green and red wires over, and then that'll mean that the correct signal lights up. So just that one to do now, and we are done. Okay, so I've got the next one wired up. I've just started using random SCART lead colours because I'm running out. But anyway, we've got green to green and red to red, and green to green and red from there. So we've gone from there to that terminal block there for each of the colours. Again, apologies for dodgy camera work while I stand up. Let's see if we've got it right. No, we haven't. This is for the straight on direction. We've got it set straight on. Signals at red, we cannot go straight on. So once again, been quite unlucky, but that's good because I get to show you on video. But once again, all we have to do is swap round that wire for that wire, that wire for that wire, and it should be green for the straight on direction. Okay, so that's them two wires swapped around. Apologies again for dodginess. Just knock this over. You can see we've got green for the straight on direction and red for the direction to the points. So that is those two signals wired up. So what I shall do, get the camera back in the tripod, and I'll flick them over under power just to check that everything works okay. But we have indeed replaced the point, and we have indeed got two working signals. Lovely. Okay, so there we go. We have successfully replaced the point, and we have successfully got two working lights. I've just turned them round so the camera can see them. Obviously, they'd normally be facing, let me think about it, that way. And this one would be facing that way because of the direction of the running lines, but I've just got them pointed towards the camera so you can see them. So, pretty successful. It's very, very warm, so I'm going to be fairly brief in this end section. And what I would really like to do is hoover all the stones up and give you a tour round of the bits of scenery that I've been doing, and give you a look at this hill a bit more, and the stuff at the back you can probably just see, or you might have seen earlier. But honestly, it is very warm in the loft. I'm just waiting for my digital clock to tick over again and tell me how warm it is, but it is very, very warm. Obviously, I've got soldering irons, I've had lamps to illuminate underneath to see what I'm doing. I've been working in a tight space. So what I shall do is, tomorrow morning, when it's a little bit cooler, I'll come up the loft, tidy up, and I'll film a quick whiz round the layout so you can see what I've been doing and so you can see what I'm going to be doing next. But 32 degrees, it's just come on my clock. It cycles through different modes. 32 degrees it is in here, so very, very warm. But what I'll do, I'll just give you a quick demo of it switching over and proving to you that it still works. But yeah, fairly happy with that. We haven't destroyed anything. We haven't broken anything. We've replaced this point so trains can now go over, hopefully, very nicely and smoothly. We've got test coach here, and hopefully these signals will operate properly with the point motor. So the point panel is on. The capacitor discharge unit is charged up, hopefully. So let's flick the switch. And let's see what happens. Have both signals gone to red? Yes, they have. The point flicked over. So this is signalling to the main line that no, you can't come on because it's set to go down there. That one's signalling no, you can't go straight on because it's set to go onto the main line. Sorry, it's not set on to go to the main line. It's set to go into the crossover. So yeah, I'm pretty happy with that. That point, hopefully you heard and saw, changed over when I flicked the switch. This signal's on red for the main line, can't go on the main line because it's crossover. That one's on red for the main line, can't go through the main line because it's on the crossover. And hopefully, if I just tilt that pole out of the way, this coach should now, without any problems, get that signal out of the way, traverse across there, which it does. Lovely. So that's all the track work at Highbrook End, back working again properly. I'll tempt fate now by closing the closing the crossover again. So let's just reach for the correct switch. And yep, that one's got to green. That one has just missed slightly. I think there's a bit of ballast stuck. Yeah, there is. Just give it a poke from underneath and it's worked. Yeah, there's a bit of ballast stuck there, which I'll clean up. But points working, signals are working, everything's working. So, thank you very much for watching. Hopefully it's been easy enough to understand. I think that one's flickering. Was that one flickering? Then it might have been. Probably just want some contact cleaner on it. But everything is working, the points work, we've wired some signals in, everything's how it should be. And of course we can now get coaches across that crossover when it's set to go over the crossover. Perfectly fine. So, thank you very much for watching. Hopefully it's not been too difficult to understand. Hopefully everything's been clear. And yeah, thank you very much for watching, and I will film that quick whiz round the layout tomorrow. Simply because it is far too warm up here at the moment, and I think I'll go downstairs and have a cold one. Thank you very much for watching, and hope to see you again soon. The way I'd actually wired the signals up to start off with, you know, when I said for both of them, oh, I've done it wrong, I need to swap the wires over. Yeah, that was actually correct all along, because I forgot the fact that on the 4th radius line, the trains run this way, and on the 3rd radius line, they run that way. So, you know, this signal actually wants to be red until the crossover's open, because if trains normally run that way, you can't just be backing another train up at the same time. So that signal there actually wants to be red until the crossover's open, because that's saying yes, you can use the crossover to get on the 3rd radius line. And similarly with this signal over there, trains normally run that way, so that signal facing that way wants to be red in normal operation, because obviously you can't have two trains running in opposite directions. So that signal actually wants to be red until the crossover opens, at which point the train will reverse onto there. So I was right all along before I started swapping wires over. those signals are actually, or were actually right before I swapped them over. So I shall go and swap them over now, and I shall get out of the loft because I believe it may have just ticked up to 33 degrees in here, and I am very, very sweaty and warm indeed. So I'll flip those over for you, and then I'll get out of here before I melt. There we are, both signals on red as they should be. So that one should be facing that way, and this one should be facing that way. Eh dear, I think the heat's getting to me. I may have been speaking Spanish for this entire video, I might not have noticed it's been that warm. Anyway, thank you for the second time for watching, and I'll hope to see you again soon. Ta-ra, and take care.